Hi friends, today I am giving a lecture on Hamiltonian cycles. Hamiltonian cycle is one of the application of backtracking. So Hamiltonian cycle is a round trip path starting from starting vertex, visiting all the vertices in the graph exactly once and starting and returning to the starting vertex. So that means visiting all the vertices in the given graph exactly once except starting vertex and ending vertex and return to the starting vertex. So that is called Hamiltonian cycle. So suppose we can take a given graph, that is A, B, C, D, E, F. Suppose we can take a graph this graph. So for this graph, how to find out the Hamiltonian cycles for the given graph? So for example, what is Hamiltonian cycle? So the Hamiltonian cycle start with vertex A and visiting all the vertices exactly once and returning to the starting vertex. For example, we are starting with vertex A and go to vertex B, next go to vertex F, next go to vertex E, next go to vertex D, next go to vertex C, next go to vertex A. So here starting vertex and ending vertex both are same. The remaining vertices in the given graph visited exactly once, starting from the starting vertex and returning to the starting vertex. So if these conditions are satisfied, then we can say that it is a Hamiltonian cycle. So for this graph, how many number of Hamiltonian cycle exist? That can be find out by using state space tree. So the state space tree representing all the solutions for the given graph. So all the Hamiltonian cycles for the given graph can be represented by using a state space tree. So how to draw the state space tree and find out how many number of Hamiltonian cycle exist for the given graph. So let us start. So first we are taking a starting vertex, that is A. A root node is the starting vertex. So what are the adjacent vertices for vertex A? So A is connected with vertex B, A is connected with vertex C, and A is connected with vertex D. So B, C, D vertices are adjacent to vertex A. So now we have to take vertex B, next vertex C, next vertex D. Now we have to take the leftmost node, that is vertex B. So now consider the vertex B. What are the adjacent vertices for vertex B? So for vertex B, the adjacents are B is connected with A, B is connected with C, B is connected with F, and also B is connected with E. So what are the adjacents for B? A, C, E, F. But A is already visited, So what are the remaining vertices for adjacent vertex B? C, E, F. So C, E, next F. C, E, F. Next we go for leftmost node, that is C. Now consider vertex C. What are the adjacent nodes for vertex C? That is, C is connected with A, C is connected with D, C is connected with B, C is connected with E. So A, B, E, D. A, B, E, D. So A and B are already visited. The remaining are E and D. So for vertex C, the adjacent nodes are E and D. E and D. Next we have to go the leftmost node for vertex C, that is vertex E. So what are the adjacent nodes for vertex E? E is connected with F, E is connected with B, E is connected with C, E is connected with D. But so B, C already visited, only the remaining adjacent vertices are D and F. So D and F. D and F. Next we have to go the leftmost node for vertex E, that is D. So what are the adjacent nodes for D? So D is connected with C, D is connected with E, D is connected with A. So A, C, E. So all A is already visited, C is already visited, E is already visited. So no more visiting of any vertex that are adjacent to vertex D. Okay. So the path contains A, B, C, E, D, but F is not there. F is not there, so it is a dead end. F is not there, so it is not a Hamiltonian cycle. It is not a Hamiltonian cycle. Next, we have to backtrack to E. Next, what is the right hand side node for vertex E? That is F. So what are the adjacent nodes for F? F is connected with E, F is connected with B. So B and E already visited. Okay. So consider this path A, B, C, E, D, E, F, but D is not there. So this is also dead end. It is not a Hamiltonian cycle. It is not a Hamiltonian cycle. Next, we have to backtrack to E. We have to backtrack to C. So consider node C. The right hand side node is vertex D. So what are the adjacents for vertex D? That is A, C, E. So A is already completed, C is already completed, but E is not there. We have to write E. Next, what is the adjacent vertices for node E? So E is connected with F, E is connected with B, E is connected with C, E is connected with D. So B, C, D, F. B, C, D already completed, but F is not there. So we have to write F. Next, what are the adjacent nodes for node F? B and E. So B is already completed, E is already completed. So consider the path A, first visit A, next go to B, next go to C, next go to D, next go to E, next go to F. So after visiting F, we are returning to the starting vertex, but there is no direct edge between vertex F and vertex A. But via B is there, but B is already visited in that path. So we have to go from vertex F to vertex A. So second time vertex B is to be visited, but it is not a according to the definition of Hamiltonian cycle, each and every vertex visited exactly once except the starting vertex and ending vertex. But vertex B is not a starting vertex. This vertex is to be visited second time for returning to the starting vertex for the given path. So then we can say that it is not a Hamiltonian cycle. It is not a Hamiltonian cycle. Next, again we have to backtrack to E, backtrack to D, backtrack to C, backtrack to B. Next, we go for second adjacent vertex for vertex B. So what are the adjacent nodes for vertex E? So B, C, D, F. So B is completed, only C, D, F are not there. So that is, so C, D, F. C, D, F. Next, consider the leftmost adjacent vertex for vertex E, that is vertex C. So what are the adjacent nodes for vertex C? So C is connected with A, B, E, D. So A, B, E already visited. Next we go for vertex D. Next, what are the adjacent nodes for vertex D? So A, C, E. A is completed, C is completed, and E is completed. So in this path, vertex F is not visited, so it is not a Hamiltonian cycle. It is not Hamiltonian cycle because vertex F is not visited. Vertex F is not visited. Next, we have to backtrack to C, backtrack to E. Next, we are considering the vertex D, that is adjacent node for vertex E. So what are the adjacent nodes for D? So that is A, C, E. So A is already completed, E is already completed, but C is not there. Next, consider the vertex C. What are the adjacent nodes for vertex C? So that is A, B, E, D. So A is already completed, B is already completed, E is already completed, D is already completed. Now consider this path. So starting at vertex A, next go to vertex B, next go to vertex E, next go to vertex D, next go to vertex C. Next go to vertex C, but F is not there. Again we are considering B is adjacent to A, C, E. C is adjacent to A, B, E, D. A, B, E already completed. C is adjacent to A, B, E, D. So A is already completed, B is already completed, E is already completed, D is already completed. So it is not Hamiltonian cycle because vertex F is not there. Next, again we have to backtrack to D, again we have to backtrack to E, again we have to backtrack to B. Next, consider the vertex F that is adjacent to vertex B. So what are the adjacent nodes for vertex F, B and E? So B and E already visited. B and E already visited. So dead end. It is not a Hamiltonian cycle. Next we are considering again we have to backtrack to E, again we have to backtrack to B. Next, consider the vertex F that is adjacent to vertex B. Next, what are the adjacent nodes for vertex F? So B and E, B is already visited, only E is not visited. Now consider vertex E. What are the adjacent nodes for vertex E? B, C, F, D. B, C, F, D. B and F are already completed. Next, only C and D are not there. So C and D. Next, we are considering the leftmost adjacent node for vertex E, that is vertex C. What are the adjacent nodes for vertex C? A, B, E, D. A is already completed, B is already completed, E is already completed, but vertex D is not there. Next, consider vertex D. What are the adjacent nodes for vertex D? A, C, E. A is already completed, C is already completed, E is already completed. Now consider this path contains any Hamiltonian cycle. Starting at vertex A, next go to vertex B, next go to vertex F, next go to vertex E, next go to vertex C, next go to vertex D. Again, we have to return to the starting vertex. So there is a path, there is a direct path between vertex D and vertex A. So we are returning to the starting vertex. So this is a Hamiltonian cycle. Next, again we have to backtrack to C, backtrack to E. Next, consider vertex D. Vertex D, what are the adjacents are there? Yes, A, C, E. A is already completed, E is already completed, but C is not there. Next, what are the adjacent nodes for C? A, B, E, D. A is already completed, B is already completed, E is already completed, D is already completed. Check whether it is a Hamiltonian cycle or not. First, starting with vertex A and go to vertex B. Next, go to vertex F. Next, go to vertex E. Next, go to vertex D. Next, go to vertex C. Then there is a direct edge between vertex C and starting vertex A. So this is also a Hamiltonian cycle. This is a Hamiltonian cycle. Now again we have to backtrack to D, backtrack to E, backtrack to F, backtrack to B. Next we have to backtrack to A. Now consider vertex C. What are the adjacent nodes for vertex C? A, B, E, D. A is already completed, but B, E, D are not there. So vertex B, vertex E, and vertex D. Now consider the leftmost adjacent node for vertex C, that is vertex D. What are the adjacent nodes for B? So A, C, E, F. A, C already completed, E and F not there. That is vertex E and vertex F. Okay. Now consider the leftmost adjacent node for vertex B is vertex E. So what is the adjacent nodes for vertex E? That is BC, DF. BC, DF. BC already completed. Only D and F are not visited. D and F are not visited. Next, consider vertex D. What are the adjacent nodes for D? That is A, C, E. A is already completed, C is already completed, E is already completed. So in this path, F is not there. So it is not a Hamiltonian cycle. F is not there. It is not a Hamiltonian cycle. For shortcut purpose, we are using H dot M, that is Hamiltonian cycle. So it is a dead end. Now we have to backtrack to E. Next, consider vertex F. What are the adjacent nodes for F? B and E. So B and E already completed. So it is also dead end. So it is not a Hamiltonian cycle. It is not a Hamiltonian cycle. Next, again we have to backtrack to E, backtrack to B. Now consider vertex F. What are the adjacent nodes for F, B and E? So B is already visited, but E is not there. Now consider vertex E. Next, what are the adjacent nodes for vertex E? BC, DF. BC, F already there, but D is not there. D is not there. Now consider vertex D. What are the adjacent nodes? A, C, E. A is already completed, C is already completed, and E is already completed. We have to check whether it is a Hamiltonian vertex A. Next go to vertex C. Next go to vertex B. Next go to vertex F. Next go to vertex E. Next go to vertex D. Next go to vertex A. So we have to return vertex A visiting all the vertices exactly once. So this is a Hamiltonian cycle. Next, again we have to backtrack to E, backtrack to F, backtrack to B, backtrack to C. Next, consider vertex E. What are the adjacent nodes for vertex E? So that is B, C, D, F. Only C is completed. Next, B, C, F are not visited. B, D, F. D and F. B, D, F. Next, now consider vertex B. What are the adjacent nodes are there? A, C, E, F. A, C, E, F. A, C, E already completed. Only F is not there. It is F. What are the adjacent nodes for F, B and E? So B is already completed. E is already completed. But D is not there. So vertex D is not there. So it is not a Hamiltonian cycle. Next, again we have to backtrack to B, backtrack to E. Now consider vertex D. So what are the adjacent nodes for vertex B? A, C, E. A is already completed, C is already completed, E is already completed. So this is a dead end and it is not a Hamiltonian cycle. Again we have to backtrack to E. Next consider vertex F. What are the adjacent nodes for vertex F? D and E. So E is already visited but B is not there. So now consider vertex B. So what are the adjacent nodes for B? A, C, E, F. A, C, E, F. Already all are visited but vertex D is not there. So vertex D is not there. So it is not a Hamiltonian cycle. Next, again we backtrack to F, backtrack to E, backtrack to C. Next, consider the vertex D. We have extended vertex D. So what are the adjacent nodes for vertex D? That is A, C, E. A is already completed, C is already completed, but E is not there. So now what are the adjacent nodes for E? So B, C, D, F. C, D already completed, but B and F is not there. B and F. So what are the adjacent nodes for B? So that is A, C, E, F. A is already completed, C is already completed, E is already completed, but F is not there. Next, what are the adjacent nodes for F, B and E? B is already completed, E is already completed. Check whether it is a Hamiltonian cycle or not. A, C, D, E, F. But vertex B, it is not a Hamiltonian cycle. Okay, Hamiltonian cycle. Because there is no edge between F and A. But already all vertices are visited, but there is no direct edge between F and A. So it is not a Hamiltonian cycle. Now we have to backtrack to B, backtrack to E. Now consider vertex F. So what are the adjacent nodes for F? B and E. So B and E. B is not there. E is already completed. Now what are the adjacent nodes for vertex B? So A, C, E, F. A is already completed, C is already completed, E is already completed, F is already completed. Now we have to check whether it is a Hamiltonian cycle or not. A, C, D, E, F, B. So there is a direct edge between starting vertex and B. So this is A. So it is a Hamiltonian cycle. So this is the first Hamiltonian cycle. This is the second Hamiltonian cycle. This is the third Hamiltonian cycle. And this is the fourth Hamiltonian cycle. Now we have to backtrack to B, backtrack to F, backtrack to E, backtrack to D, backtrack to C, backtrack to A. Now we are consider the vertex D. Consider vertex D. What are the adjacent nodes for D? A, C, E. So that is A, C, E. It is A, C and E. Now consider vertex A. What are the adjacent nodes for vertex A? Vertex A is B, C, D. So D is already completed, but B and C not there. So B and C. Now consider vertex B. What are the adjacent nodes for B? A, C, E, F. A is already completed. B, C, D. A is already completed. So C, E, F. C, E, F. C, E, and F. So now consider vertex C. A adjacents for C is A, B, E, D. A, B, D is already completed. E is not there. Now consider vertex C. Adjacents are B, C, D, F. B, C, D already completed. F is not there. What are the adjacent nodes for F? D and E. Now consider whether it is a Hamiltonian cycle or not. A, D, A. So it is visited second time. So C, sorry. Now consider vertex D. What are the adjacents? So D, A, C, E. A is already completed. Only C and E is not there. C and E. Now consider vertex C. What are the adjacents? For C, A, B, E, D. A, D already completed. Only B and E is not there. Vertex B and vertex E. Now consider what are the adjacents for vertex B. So A, C, E, F. A is already completed, C is already completed, but E and F is not there. So E and F. Now consider vertex C. What are the adjacent nodes? B, C, D, F. B, C, D already completed, but F is not there. Now consider F. What are the adjacents for F? B and E. B and E already completed. So check whether it is a Hamiltonian cycle or not. A, D, C, B, E, F. There is no direct edge between F and A. So it is not a Hamiltonian cycle. It is not Hamiltonian cycle. Again we backtrack to E, backtrack to B, backtrack to F. Now consider vertex F. What are the adjacent nodes? D and E. B is already completed. Next, E is there. Next, what are the adjacents for E? B, C, F, D. B, C, F, D already completed. So consider the path A, D, C, B, F, E. But there is no direct path between vertex E and vertex E. So all vertices are visited, but it is not a Hamiltonian cycle. Next, backtrack to F, backtrack to B, backtrack to C. Next, consider vertex E. What are the adjacents for E? B, C, F, D. So C is already completed, D is already completed, C, D already completed, DF is not there. So that is B and F. Now consider vertex B. So what are the adjacents for vertex E? A, C, F, E. A is already completed, C is already completed, E is already completed, but F is not there. So now consider F. What are the adjacents for there? B and E. Already visited. Now consider the path A, D, C, E, B, F. There is no direct edge between F and A. So it is not Hamiltonian. Again backtrack to B, backtrack to E. Now consider F. So what are the adjacent nodes for F? B and E. So B, E already completed, but B is not there. Next, consider vertex B. What are the adjacent nodes for B? A, C, E, F. A is already completed, C is already completed, E is already completed, F is already completed, D is not there. D is not there. So it is not a Hamiltonian cycle. Now consider backtrack to F, backtrack to E, backtrack to C, backtrack to D. Now consider vertex E. So what are the adjacent nodes for vertex E? That is B, C, F, D. So D is already completed. Only B, C, F. B, C, F. B, C, F. Next, what are the adjacents for B? A, C, F, E. So A and E already completed. So only F and C is not there. So that is F and that is C. So what are the adjacent nodes for F? B and E. B is already completed, E is already completed, but there is no direct edge between F and A, so it is not a Hamiltonian cycle. It is not Hamiltonian cycle. Next, consider vertex C. What are the adjacent nodes for C? A, B, E, D. So A is already completed, B is already completed, E is already completed, D is already completed. So all are completed, but F is not there. So F is not there. So it is not a Hamiltonian cycle. Now consider backtrack to B, backtrack to E. Now consider vertex C. What are the adjacent nodes for vertex C? So A, B, E, D. A is already completed, D is already completed, E is already completed, but D is not there. D is not there. So now consider what are the adjacent nodes for D. That is A, C, E. A is already completed, C is already completed, E is already completed. Okay. So it is not a Hamiltonian cycle. Now backtrack to C, backtrack to E. Now consider vertex F. What are the adjacent nodes for F? So B and E. E is already completed, but B is not there. B. Now consider B. What are the adjacent nodes for A, C, F, E? A, F, E, but C is not there. So that is C. Next, what are the adjacent nodes for C? A, B, E, D. A is already completed, B is already completed, E is already completed, D is already completed. Check whether it is a Hamiltonian cycle or not. A, D, E, F, B, C. Then we go for A. So it is a Hamiltonian cycle. Okay. So this is the fifth Hamiltonian cycle. So for this graph, so there are 5 Hamiltonian cycles. So first Hamiltonian cycle is, so this one, that is A, B, F, E, C, D, A. Next, second Hamiltonian cycle, A, B, F, E, D, C, A. Next, third Hamiltonian cycle, A, C, E, A, C, B. A, C, B, F, E, D, A. This is third Hamiltonian cycle. And fourth Hamiltonian cycle, that is A, C, D, E, F, B, A. Next, fifth Hamiltonian cycle. A, D, E, F, B, C, A. This is fifth Hamiltonian cycle. So, for this given graph, how many number of Hamiltonian cycles are there? There are 5 Hamiltonian cycles. So, in this way, we have to find out the Hamiltonian cycles for the given graph by using state space tree. So, thank you for watching this video. If you like this video, please subscribe my channel, Divvela Srinivasa. Thank you.